Let's look at the reading real quick. Common core is APR, which stands for algebra. And we're going to find polynomial roots and rational expressions, okay? So 3, it says identify zeros of polynomials by factoring to construct the graph. Now, today, the kind of graphs we're going to get are going to be number lines. You won't see a y variable. In fact, if you look at your notes, there's no y, is there? So everything's going to be on a number line. There's no y variable, so it's just going to be on a number line, okay? So how do we do it? Well, move all terms to one side, factor to find the zeros. Once you get the zeros, we're going to make border points on our number line. Then we're going to graph and test our intervals, okay? And I'll show you what that means when we do it. And then we'll put the answer into interval notation. If we have a rational expression like a fraction, like that one, we got to be careful of dividing by zero. So it makes additional border lines, okay? Because you can't have values that are undefined, okay? So let's take a look at this. So again, my common core is A for algebra, A, P are polynomials and rational functions. 3, which states identify zeros of polynomials by factoring to construct graphs. And Marie, keep me straight, okay? Okay, everybody has a calculator, right? Because we're going to let the calculator do some of the work for us, right? So first of all, let's go through this, okay? Step 1, move all the terms to one side. Well, that's already been done, right? See that? So that's already been done. There's nothing over here, right? Step 2, factor. Hey, this one's already been factored for us. Sweet. Okay, so now right at the bat, to find our border points, we would have, well, x plus 3 equals 0.
That's 2 of them.
Yeah, we'd have another x plus 3 equals 0. We'd have an x minus 2 equals 0. And we'd have an x plus 1 equals 0, right? So if I solve, I got x equals negative 3, x equals negative 3, x equals 2, and x equals negative 1. Those are my border points, all right? So now, what I want to do is graph this on a number line. On a number line because there's no y variable. So I just get my y. Okay, make a number line. And I don't have to have all of the numbers, but I have to certainly have these important ones. These are the ones that have to be on the number line. So I'm going to have a negative 3, 1, 2, all right? Easy question, easy question. Open or close dots? Open or close dots? Open or close dots? Open. There's no little equal sign, right? Open dot. So I'm going to put an open dot then at negative 3. An open dot at negative 1. And an open dot at 2, okay? Now, what we want to do is find out, for instance, if we plugged in a number, say 0. If I plugged in 0, would that whole value be greater than 0? Would it be positive, right? So if I plug in 0, I could plug in 0 to test it. Plug in 0, I'd have a 3 squared minus 2 times a 1. Is that positive or negative? Well, you could plug in, here's the way the book wants you to do. The book wants you to plug in a value over here to see if it's positive, because it's greater than 0. It wants you to plug in a value, any value in here to see if it's positive. It wants you to plug in a value here to see it's positive. And it wants you to plug in a value here to see if it's positive. I'm saying positive because it says greater than 0, right? Anything that's greater than 0 has to be positive, right? So that's one way to do it. An easier way to do it, I'm going to show you, is just to graph the original polynomial. So we're going to graph it on our calculator, right? So this is the way I like to do it. I mean, I prefer to use the calculator as much as I can, right? So I'm just going to go parentheses. Let's go x plus 3 squared parentheses x minus 2 times an x plus 1 and I'm going to graph it. I don't have to see all the graph, I just need to see enough of it, okay? Well, I can see right off the bat what's going on. So, bring it down. If I look at my calculator, then the part of the graph that is up here, those are the positive values, right? Aren't those? Everything up here above the x-axis is positive, right? Everything down here is negative, right? So where is it positive? Well, it's positive at 2 over. Isn't it positive? In fact, I can do a trace button. In fact, if I do a trace and put in 3, I get 144. Is that greater than 0? Yes, so I want to shade 3. Put in 4. I get 490. Is that greater than 0? Yes, so I want to shade 4. In fact, I want to shade everything from here on out, right? So if I take a look at negative 1, sure looks like it's going to be negative, you agree? But I could trace it, negative 1, and I get 0. Okay, negative 1, well, that makes sense. Let me try 1, sorry, 1. So I get negative 32. Is negative 32 greater than 0? Is negative 32 greater than 0? It's not. So at 1, I got a negative value. So none of this in this region should be shaded. Everything within this region is going to be negative, which is less than 0. So don't shade that region, okay? So let's test this region. Okay, if that's negative 1, let's test negative 2. Oops, sorry. Let's test negative 2. I get 4. Is 4 greater than or equal to 0? Yes, so everything within this region is going to be positive. You can kind of see it. It's all that region here. So I want to shade that. Now, normally they go in and out, but you got a double root, right? See my double root? Right there. So what about at negative 4? Negative 4 gives me 18. Is that positive? Yeah. So it means it's greater than 0. So I shade this region also. So there's my number line. So let's see if we can describe that in interval notation. I've got 1, 2, 3 regions to show. Okay, so first of all, my first interval would be negative infinity to negative 3. That's my first interval, right? Negative infinity to negative 3 is part of my answer. But not including negative 3, right? So I use a parentheses. Negative 3 is not an answer, so I use a parentheses. And then I go or negative 3 to negative 1 is a value, right? Again, I use parentheses because it's not equal to. Or I'll go 2 comma infinity, okay? So I've described my number line using interval notation. Thumbs up? Not too bad? Sideways? Okay. Okay, let's do another one. Okay, on example 2, we're going to have to do some factoring, but that's okay. Step 1, move all terms to the other side, okay? Right? So let's bring this 13x and put it right there. You alright with putting it right there? So I'm going to go 2x cubed plus an x squared minus a 13x plus 6 greater than or equal to 0, okay? Oh boy, it won't factor. If it does, I don't know what to do. So what do I do if I can't factor? Right, let's use our poly button. So it won't factor. I have no clue. So let's use our poly button. What the heck, right? So I'm going to go to apps. Go to my poly. Okay. Order 3, right? Order 3. I'll go 2, 1, negative 13, 6, right? And I'll solve. It's thinking. It's going to think. Oh, it would have factored. What do you know? But it would have taken me a while to get it to factor, right? You agree? Mm-hmm. So here's my border points. So my border points are at x equals 1/2, x equals 2, and x equals negative 3. Okay, so, oops, negative 3. There you go. So those are my border points. Let's put my number line down. Let's see, negative 3. Solid or open? Solid or open?
Solid.
Solid. Everybody agrees? Solid. So let's put a solid dot at negative 3 because it's equal to. Let's put a solid dot at 1/2. And let's put a solid dot at 2. Okay. Oh, my 1/2's in the wrong place. Darn it. Good thing I have whiteout because I make mistakes. all the time. It's all good though. There you go. Fix that. There we go. Alright, so here's the way I would do it. The book wants you to take 3 and plug 3 in and see if it's greater than 0. The book would like you to take 1 and plug 1 in and see if it's greater than 0. Whoa. Cheney, Washington. No, I don't think so. I don't know who's a Cheney, but I'm not taking it. Okay. The book wants me to plug in maybe -1 and see if it's greater than 0. And the book wants me to plug in -4 and see if it works. But we have an easier way. Let's just graph it, okay? So let's go to y equals, let's put in our equation, clear that, 2x to the third plus x squared, subtract 13x plus 6. I'm going to graph it, okay? Okay, now, I don't have to see all of the graphs, right? I want to say this. I do not need to fix the window. Okay, oops, I don't need to see the fix the window. All I need to do is use my trace button, okay? So I'm going to use my trace button. So first of all, let's test 3. Let's test 3. So I want this to be greater than 0, so I'm looking for positive values. It's going to be greater than or equal to 0. I'm looking for positive values. So if I test, I go to trace, and I go to 3. I get 30. Is 30 positive? Is it greater than 0? Is 30 greater than 0?
Yes.
So shade it, which means I'm going to shade 3. I'm going to shade everything from 3 over, right? Awesome. That's one interval, okay? Test 1. Now, normally they go every other. In fact, you can even see it from the calculator. It's not going to work. But test anyway. Put in 1. I get a -4? No. Because it's supposed to be positive, right? It's supposed to be greater than 0? Nah. Let's test maybe -1. I get 18. 18's positive.
Yeah.
So let's shade that region, okay? The whole region. And let's try -4. Let's test -4. I get -54. I don't want that. So I get these two regions. All right, that's not so bad. So if I'm going to do this in interval notation, I'm going to go bracket. Bracket, because it's a solid dot, right? Bracket, -3, comma, 1/2. Bracket, or bracket at 2 comma infinity parentheses. It has to be parentheses because you can't get to infinity to put a dot, can you? You can't get to infinity, so you just have to leave that, okay? Thumbs up? So the calculator really does it. In fact, you can even see it from the calculator what's greater than 0 and what's less than 0, can't you? It's actually pretty easy, okay? All right, turn the page. All right, now, third example can be just as terrible if you didn't have a calculator. But we have a calculator. So again, I'm going to factor. The first thing I'm going to do is factor, okay? Okay. I've got an x minus 3, x minus 1. Okay, think about that. Multiples of 3 that make a -4. And I'm going to have an x minus 5, x plus 1, okay? Multiples of -5 that make -4. Everybody okay with that? So my border points are this. My border points will be at x equals 3, x equals 1, and at x equals 5, and x equals -1. Okay, write that down, and then I'm going to make a change. Okay, so I got my border points from 3, because that'll make it 0. From 1, because that'll make it 0. From 5, because that'll make it 0. And from -1, because that'll make it 0. Now I'm going to make one small change. Not equal to, not equal to. It's going to be a border point, but it can't equal those, okay? So when I do my number line, I'm going to do open circles there. Open circles, okay? Because if you let those values be, you divide by 0, right? So let's do my number line, okay? So I take my number line, and I've got, let's see, -1, 0, 1, 2, 3, 4, 5, 6, okay? Solid dot at 3 because of the equals, right? Solid dot at 1 because of the equals. Open open dot at 5 because it can't equal 5, right? And open dot at -1, okay? Now, where do I shade? Let's look at it. Let's put it in the calculator. Let's take a look at it, okay? So clear y equals, clear that. I'm going to go parentheses. I'm going to go in x squared minus 4x plus 3 parentheses divided by parentheses x squared minus 4x minus 5 parentheses. Okay? So I have it in. I'm going to look at it, and then I'll test my regions, okay? Graph, okay? And some of them you can see, okay? You can kind of see where they are. Yeah. So what we're looking for, since it says greater than, we're going to test for positive values, right? Because if we want this expression to be greater than 0, anything greater than 0 is positive numbers, right? Positive numbers. So I'm going to test my regions. So let's test -1. Okay, I can already tell -1 is going to be positive. Testing at -1, you get, oh, hold on, graph. Lost one. So if I try -2, try -2, right? -2, I get a, oh, shoot, what's going on? Trace. There we go. I get a 2.14. Is that a positive value? And it actually looks like it's above, right? Kind of, I mean, some of this seems obvious. I will test all the points. You guys probably go, come on, Mr. Davies, don't you see it? It's already above 0. You guys see that? Right? So I'm going to shade all of that. If I test 0, I get a -0.6. I get a -0.6. Nope. Let's test 2. I get a positive 0.1111. That's a positive value, so I want to shade that region. If I test 4, I get a -0.6. Nope, don't shade that. Let's test 6, and I get a positive 2.14, so I just, there you go, all right? See how easy that is? Yeah. As long as you can graph it, you can test your region, you're in good shape, okay? So then finally, interval notation, we're going to go parentheses, -infinity, comma, -1, parentheses, because it does not equal -1. Or bracket, because it equals it, 1, 3, bracket, right? Or parentheses 5, infinity. There's my solution in interval notation. Okay, thumbs up. Not that bad. Okay, good. So here's our homework. Page 316, 5, 19, 23, 37. Okay? How's that?